Good morning. We are talking about classifying numbers. This is the first Scribbles and Jots for Unit 2. And classifying just means that we are putting numbers in different types of categories or groups. Okay? So there are several groups that we're going to talk about today. Natural counting numbers are pretty much what they sound like. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way through a million, billion, trillion, as big as you can get. So they are all whole numbers. All whole numbers. It does not include zero, though. So it's all whole numbers, but it doesn't include zero. So anything you would count people in is a natural counting number. Through the highest you can think of. Okay? Whole numbers is a category in itself, and that is all natural counting numbers. They might also be natural numbers or counting numbers. There should probably be a slash right there because that can be either or. Plus zero and zero. So all natural counting numbers and zero are the way we classify those. So natural counting numbers are anything you would count people with. 1 through billions, trillions, gazillions, however high you can count. Whole numbers are all of those plus zero. So zero is the only difference in these two categories. The only difference is zero. Integers are all whole numbers, and this is a little different, they're opposites. In math, an opposite is negatives and positives. And you may have heard of negative numbers. I know you haven't used them a whole lot yet. We're going to learn how to use those this year. So if I had 4 as a whole number, its opposite would be negative 4. If I had 100 as a whole number, its opposite would be negative 100. If I started with negative 2.5, oh, that's not true. That wouldn't be an integer. I apologize. We'll get to why. If I had negative 2, its opposite would be positive 2. All whole numbers and their opposite. Negative 2.5 is not an integer because it's not whole. Rational numbers. All numbers that can be written as a fraction, a repeating decimal, or a terminating decimal. All numbers that can be written as a fraction, a repeating decimal, or a terminating decimal. So we all know what a repeating decimal is. We have seen that 1/3 equals 0.3 repeating. We've seen that. We know that means that the 3 goes on and on and on, and there's just never an end to that. Terminating just means exactly what the word sounds like. Terminating means to end something. So it ends. So any decimal value that has an ending, 0.5, 0.47. There aren't a whole lot of numbers that aren't rational, but there are some. The most famous that you have probably heard of is pi. And it equals 3.14, and it goes on and on forever, and it never repeats, and it never ends. And you've probably heard that before, but that would be a non-rational number. So we're going to put a mark through that because it's not rational. Now, based on our definitions, take a minute, see if you can place these in the right place, and I will... Oh, wait, actually, let's go ahead and name each of these categories. And then you can go and see if you can put the numbers in the right place. So the smallest circle is the natural counting. The largest circle is rational. Rational, all the numbers we're going to use this year are considered rational. So you don't have to worry about anything outside of that. All the numbers we're going to use this year are rational, which means we are not going to get to pi. And then we have whole numbers here and integers here. Next year you'll add a couple of categories, including non-rational numbers. But this is where we're starting this year. So I'm going to look over here. I want you to look over here at this group of numbers right here and see if you can figure out where they would go. Pause the video, try it yourself, and then check back and I will show you where they go. Okay, so I'm going to look for all my natural numbers. 4 is a whole number, so I'm going to put it in natural counting. I don't want to count 3/4 of a person. Negatives don't count. 0.5. There's a fraction. We'll come back to that. 0. 0 is not natural counting. 0 is a whole number. It is the only whole number that is not a natural counting number. 1.5, 6.6. Okay, so none of those are natural counting except this one. And it looks like a fraction, but we have said that all fractions are, yes, division problems. 6 divided by 3 is 2, which makes that a natural counting number because the value of 6 divided by 3 is 2. All right, so we've used that one. Whole numbers. We've already said 0 is a whole number. It is the only, when you have a natural counting category, 0 should be the only number in the whole number category. Integers are all whole numbers and their opposites. So I've got -7, which is an opposite of a positive whole number. 0.5 is not a whole number. 1.5 is not. None of the rest of these are whole numbers or their opposites. So 3/4 would be rational counting. 0.5 is rational. Not counting, is rational. 1.5 is rational. 6.7 rational. -0.2. So most of the numbers we use will fall in the rational category. But that is how we classify numbers.